All right, pre-calc students, we're back for day 2 of ellipses, excuse me. All right, so just to remember, an ellipse is what? The set of all points in a plane such that the sum of the distances from two fixed points, which we call foci, is constant. All right? The set of all points in a plane such that the sum of the distances from two fixed points is constant, okay? So what does that mean? Well, that means in this picture then, if I'm picking this point on my ellipse, well, maybe I call this D1 and I call this D2. And when I add D1 plus D2, I get a number. And then what happens if I switch? Sorry about that, guys. What if I switch and maybe I choose this point and I call this maybe D3 and D4? Well, the sum of D3 and D4 has to be the same as D1 and D2, okay? So we could say this, right? The sums are constant. What's really nice, actually, and we can go even further, and we'll probably have seen this in our presentation during class, is D1 plus D2, or whatever, the sums, will always equal 2 times the major radius. All right, so that's something that you can remember. It does help with the proofs, but again, I don't think that's something that we'll assess you on, but that is something that helps you kind of move on and get these equations, okay? All right. Now, there's a couple of other things that we could do, such as we know that this is called the center. All right. We know that as this is currently drawn, because this is going, like the x direction is going longer than the y direction, well, we would call this the r, oh crap, that doesn't work. Sorry, guys. This is the r minor, the minor radius, which of course then means that if I went like this is the r major. All right? Okay, sorry about that. The last thing, and I know I've already made this picture just miserable, but hopefully you guys can see. I'm going to try to make them nice and big. All right, I'm going to highlight these points. Those are those two fixed points. That is called a focus. That is called a focus. And together, two focuses make the foci. All right? Okay. So now we need to know the definition of the focal radius. The focal radius is just the distance from center to each focus. All right? So that would be right here in our picture. All right? One more line just to make our picture even better. That is r sub f. All right. Holy cow, that is terrible. I apologize. Okay, so we have this equation, and we can always get the focal radius by using r sub f squared is equal to r major squared minus r minor squared. All right, so we're going to come back to this in a second, but I'm going to start example 1, and then we're going to come back and we're going to do some calculations in this section. Okay? Okay. So here we go. graph this ellipse as well as its foci. A couple of things we need to remember. Well, we know that to graph we need a center. Our center, because there is nothing being added to x or nothing being added to y, or subtracted for that matter, we know we're going to be at 0, 0. We also know that because 25 is under x squared, we can get r sub x. R sub x is the square root of 25, or 5. R sub y, then, is square root of 169, which is 13. Now we need to remember that yes, we like knowing x and y. It's probably good for us to know what the major and minor are. So obviously, well, maybe not obviously, but hopefully obviously, we know that the bigger number is going to be the major. Okay, so I know that this is major. I know that this is minor. All right, R and R. All right, and this is great because now I can graph this thing. Pretty easy, right? I know that my center's at 0, 0. I know I'm going 5 in the x direction. So 1, 2, 3, 4, 5, and 5. And then 13 in the y direction. So 3, 6, 9, 12. All right, 13. So that means it's going to be 2 from the bottom. All right, something like that. And we do our very best to sketch this. Again, I'm not grading you on your art skills, but please do your very best to make it curvy. All right? And so now that we have some information, some data about this ellipse, not data, I don't know, I'm tired, sorry guys. Now that we have some information about the major and minor radiuses, we can go ahead and we can calculate the focal radius, because then we can plot our foci, excuse me. All right? So we see 13 and 5. Those are our major and minor radii. So we'll plug in. R sub f is going to equal, let's see here, our major was 13, so 13 squared. And our minor was 5, so 5 squared. And so r sub f squared equals 169 minus 25, which is 144. And when we square root both sides, we get that r sub f is equal to 12. All right, equal to 12. So that means then that our foci have to be 12 units from the center. Now, am I going to go 12 to the left or right? No. Okay, our foci have to be within the ellipse, so that means that I can go ahead and I can plot them 12 units from the center. And I have to go up and down here because my major axis is the y-axis. So if this was 13, well then this is 12, and this is 12. And I can call this F and F. Maybe I'll call it F1 and F2. Okay? So there's that. Hopefully we don't think that's too bad. Now yesterday we talked about eccentricity a little bit. And eccentricity is kind of a crazy looking formula, but I hope we just learned that our major squared, right? The major radius squared minus the minor radius squared, that's something different now, especially, or for ellipses at least. All right? We just learned that the major radius squared minus the minor radius squared is actually the focal radius squared. So I am going to completely replace the numerator, well, part of the numerator, excuse me. I need the square root, but I can now call this r sub f squared, and then this is still over r sub major. Okay? Well, taking the square root of a square just means we have r sub f over r sub major. And so now we have a better formula, an easier formula for the eccentricity of an ellipse. Okay? So let's use the same example that we were just working on and get that eccentricity. All right? So if we go back to the page before, we knew that r sub f was equal to 12. We knew that r major was 13. And so when we now use this new formula, our eccentricity is just 12 over 13. All right. Now, another thing that eccentricity does, I know we already talked a little bit about it yesterday, how a circle has an eccentricity of 0, a parabola has an eccentricity of 1. All right. We can tell because of this 12 over 13 that it's going to be kind of a skinnier, thinner ellipse. All right. The closer it is to a circle, the closer the eccentricity is to 0. All right. The closer the eccentricity is to 1, the kind of like skinnier, taller, or wider, depending on what the major axis is. Okay? Or is going to be, sorry. Bad English. Man, I am tired. Geesh. Okay. So, here we go. We're going to do everything now. Every single step. I'm just giving you an equation. We have to complete the square. We're going to graph. We're going to find the focal radius, and we're going to graph the foci, find the eccentricity, everything. So, first things first, we have to rearrange this. 4x squared plus 8x. All right, I'm just going to, I'm going to leave it like that. So 4x squared plus 8x and 3y squared plus 6y. I am going to move the constant over because I know I like to have the constant over on the side by itself. But hopefully you guys remember, this is not ready to complete the square yet, right? We need to have coefficients of 1, which means I'm going to factor out a 4. And now I have x squared plus 2x plus a blank placeholder. And I'm going to factor this 3 out, so y squared plus 2y plus blank. And of course that's still equal to 5, but we need to add in a couple of blank spots, right? If we add something to one side, got to add it to the other. So we complete the square. Half of 2 is 1. 1 squared is 1. So remember on the other side, that means what? We're going to actually add a 4. And what's going on over here? Half of 2 is 1. 1 squared is 1. So over here, it's going to be a 3. Cool. So the reason we do that is because now we can write it as a binomial squared. We now have 4x plus 1 squared plus 3y plus 1 squared, and that's all equal to 12. Now, if you remember correctly, our ellipse equation or formula should always be equal to 1. So we're going to go ahead and divide everything by 12. Alright, when we do that, this actually cleans up pretty nicely. We now have x plus 1 squared over 3 plus y plus 1 squared over 4, and that's equal to 1. So now we're good to go. And now we can do some things. Now we can say that the center, well, we see it's plus 1 and plus 1, so we know that our center here is going to be negative 1, negative 1. We know that our r sub x is the square root of this value in the bottom, right? So we have square root 3, which is about 1.7. We'll leave it like that. For graphing purposes, we're going to need it. And then r sub y is 2. Now we can already tell which one's going to be bigger, r sub y. So it's probably a good idea just to kind of remember that this is our major, can't spell, and this is our minor. Okay, well, we can sketch this right now. Okay, we're centered at negative 1, negative 1. So we're centered here, and we know in the major axis, the y-axis, we go up 2 and down 2. In the x direction, the minor, it's like 1.7. So something like maybe there and there. And now we could sketch our ellipse. Now I have a question for you guys. I know it's not super thin or whatever, but what should be true about our eccentricity? Should our eccentricity of this be closer to 0 or 1 than this other one? Well, let's find out. All right. So to get the eccentricity, we should probably know the focal radius first. All right. And so we use r sub f squared equals r major minus r minor. All right. So our major radius here was 2, but we have to square it. So we're back at 4. Our minor radius was root 3. We square it, so that's actually just back to 3. And so now we know that r sub f squared is equal to 1, or r sub f equals 1. All right, that's great because now we can place our foci on the graph. Please remember, they're always on the major axis, okay? Always on the major axis. So that's why I went one up, one down. So now let's see, go through. We've completed the square, we've graphed the ellipse, we've found the focal radius, we've graphed the foci from the focal radius. Now we're going to get that eccentricity. So the eccentricity, remember, for an ellipse now is way easier. It's just r sub f over r major. And so E is equal to 1 over 2. And hopefully that confirms what you thought earlier. This eccentricity should be closer to 0 than the other eccentricity we calculated. And why is that? Well, because it looks closer to a circle than this one, right? Okay. All right, so let's do some equation writing. All right, let's do some equation writing. First things first, on these, I always strongly encourage you guys to draw a picture. All right, drawing a picture is going to help. So we need to write an equation of an ellipse with foci of 0, -3 and 0, 3. All right, so let's get this started. All right, and so I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, let's start putting some of this together. So this is telling us that our foci are at 0, -3 and 0, 3. Okay, that's pretty cool. That definitely tells me that I'm centered right here at the origin, right? It's the direct middle between these foci. All right, so that's great. I also know that the minor axis is 4. Now you need to be very careful. Minor axis is the distance from vertex to vertex of the ellipse, right? It's from like edge to edge. It's not the radius. What we need to remember then is if the minor axis is 4, well then the minor radius, which we need, is actually 2. All right, the axis is the complete distance, the radius is just the half. So now I know that, again, if this is on the major axis, then my minor radius of 2 means that I am going to have points 2 to the right and 2 to the left. All right, so let's think about what we can already write. We know that the center is at 0, 0. I now can see that my r sub x is 2. R sub y, we're not there yet. We still need to do something with that. But we also know that our focal radius was 3, right? If the center was at 0, 0, up 3, down 3, so we know that that's a 3. And we're going to use these two facts to get to r sub y. All right? Because remember, we said this is the minor, this is the major. And what is that formula again? R sub f squared equals r major squared minus r minor squared. So when we plug some stuff in, we end up getting, well, 3 squared is 9. We're looking for r sub major. And we know that the minor was 2, so 2 squared, so minus 4. So now we know 13 is equal to r sub major squared. And so r major is the square root of 13. So square root of 13. Now, you're not going to have a calculator. You need to understand that 13 is between 9 and 16. Why do I say 9 and 16? Well, I know the square root of 9 is 3. I know the square root of 16 is 4. So I would say this is roughly, just for graphing purposes, about 3.6. I'm going to go ahead and check it just because I haven't done this in a while. Square root of 13. Okay, 3.6. Perfect. All right, cool. So now we can plot. Just to kind of finish up our graph, we can sketch this now. All right, there's a nice ellipse, but again, we have to remember we're looking for the equation. All right, in this problem, we're just looking for the equation. So we start, and we remember x minus h squared all over r sub x squared plus y minus k squared all over r sub y squared, and that's equal to 1. We'll plug some stuff in. And we know center is 0, 0, so we have x squared over my r sub x is 2, so 2 squared is 4. And I have y squared over, well, r sub y is square root 13. Square root 13 squared is just 13. And so now I have the equation that I am looking for. All right? Okay. Oh man, this video is getting long. You know what? I'm going to save this last example as a warm-up for class, okay? Just because I don't want to make you guys watch me any longer. All right? So I hope that some of this is making sense. The big ideas that are really going to help you, it's right on the first page, all right? Right here on the first page. This right here is going to be kind of the key to graphing foci, or if I give you information about the foci, then you're going to be able to work backwards to get whatever was missing, the major or minor radius. Okay? So kind of start thinking about this, and other than that, just keep practicing your completing the square, keep practicing the formula or the setup of an ellipse, because it's really important. You can see everything just from that equation. Okay? All right. We will practice in class. Have a great day.